Alright, this is net 223 routing and switching. The first thing we did was we reviewed a couple things about VLANs, trunking. We mentioned legacy. If you had, let's say, a blue VLAN on here and a red VLAN, you could put this port in red, this, then connect this port to a router. The red could move through and get routed and brought here into on the blue VLAN. Legacy. Now this wouldn't scale very well, so we do things like this. We create a trunk, and so from one VLAN, let's say we had a blue VLAN, when it goes, it gets tagged blue, tag comes off, it can get routed, and then it can come back, get tagged on the red VLAN, so when it comes down here it ends up in the red VLAN. Idea of using a trunk. And we talked over here a little bit about a multi-layered switch. If you had, let's say over here, you had a VLAN, I don't know, 20, and then you hooked it on this 20 port, and over here you had a VLAN 10 and a VLAN 30, let's say. So they can use the trunk to communicate here, but if you're putting those virtual interfaces in here, switched virtual interfaces inside here where you got the VLANs with IP addresses, if you want to route in between those, you have to have all those VLANs on here. So there has to be a VLAN 20 in this device, there has to be a VLAN 10 and a VLAN 30. Here you could say no switch port, and you communicate them for router. This would not be a trunk, it would be just the routing devices talking to each other. And then maybe this is going out to a WAN or something. Next page. We looked at this scenario here, and we did some IP addressing, and I'll review the IP addressing a little bit. We had 25 hosts, 10 hosts, and 5 hosts. We have 1, 2, 3 WANs, and then 4, 5. We have 6 networks. 6 networks. And then what the students were to do, they have 2 groups. One of the groups have routers 18, 19, and 20. And so that represents these 3 routers up here. I'm not sure how this group divided them up, but you could look. You could go console in and so forth remotely. And then the other group has devices 25, 26, 27. The same thing, they assign those up here to the different routers. And then what they wanted to do is have connectivity between all of the devices and also make use of, let's say, this backup link. So we thought of this as being the headquarters, and we have a WAN going out to the internet, some ISP sitting out here. And so after we get it addressed, then their goal was to configure. So you would configure those 2 interfaces on this network, whatever network you assign to it, and then one of those sides, I'm not sure where they put it, has to be the DCE, and so that would have to have the clocking. That would have to have the clocking. And the other side then would be the DTE, and that would not have the clocking. And that occurs on all 3 of those WAN links. Now here's something I noticed. Put it in blue. In here, this will be in the routing table, and this one will be in the routing table. What will not be in the routing table is how do we get to here or here. Now this one won't be in the routing table either, but you don't need it in the routing table. Nobody needs to go to that WAN. Now where they want to go are the computers here and here from here. So we can use this IP route. You can give the network name, or excuse me, the network number, whatever network they're using up here, and then the mask, and then this can be the interface to go out of. So to get up here from here, probably the best interface would be to go out of this one. And this next hop would be this address up here. Now I noticed in looking at a couple of them, some people put a static route in this router pointing at this WAN connection, which is completely unnecessary. Nobody goes to the WAN connection. What you need in here are two static routes, one pointing to this network up here and one pointing to this network here, like I described here. And then this router would need a couple static routes pointing at this network up here and this WAN over here. And then the same thing, up here we need a couple routes coming down to those two networks. Now, somebody might look at this for a little bit and they say, well, we're going to create a default route here going out and a default route here going out, so you wouldn't necessarily need a static route to here, because if this one can't find it, it's going to send it up to this router anyway. Same thing here. So you could make that point, argue that point. Okay? And then this would default out to the ISP. But this router would definitely need static routes just like this pointing down to here, and this one would need one pointing down to here. So whatever, like this example over here, whatever network is here, that network with this mask point at the interface, this interface, and the next hop. That is that IP address right there. Last thing you can do, you have your default route going out here, but you can have a backup route going this way by just adding some administrative distance here, like 200, to keep it above any, which we're going to learn about in the next week, dynamic routing entries into the routing table. Alright, so we did the IP addressing, and I'll run through this briefly. So we only have these 8 bits to work with. It says 24, that means this part's the network, so we only have that to work with, those 8 bits right there. We drew the line there because we knew we needed 6 networks and at least 25 hosts. This gives us 30 hosts. 2 to the 5th is 32. Can't use the first and last. And this will give us 2 to the 3rd, 8 networks. So I started writing out the networks here. And then I started giving the ranges here. So here was the first one, here was the second one, and then this was the last one. We jumped down and showed the very last one. we took the last one and subnetted that again. If you can follow this over here, took those 5 bits, divided them here. Now we have 8 more networks. I didn't list them all. Here's 4 of them. We could list the other 4 if we would have kept going, because we can divide those bits up, leaving those ones all there. And so you can see what we were doing. And then these /30, they would work good for the WAN connections. You could take a look and say, okay, I'm going to group these 2 and run those up where the where we had the router and the 25 hosts. You could group these. You could group these and do a little summarization. Alright. I grabbed a couple pieces of configuration and I was just going to show you a couple things. Alright. We have default has not been set. This is Cedar Falls. So there should be a default here defaulting out to Mason City. And then somewhere in here we would need some static routes. And so I got looking and I saw this IP down and down. Then I seen these 2 ports. This one's configured up and up. So I said, well, I think their cable probably hooked to this one. So I did a show controllers on that interface. And sure enough, it told me a DCE V.35 cable exists and there's no clocking turned on. So this belongs down here. Alright. And then here, down and down, we've got a DTE clock stopped on the other end. I assume the clocking's not done on the other end. The other end of that would be a DCE. And we looked at, you have data terminal equipment. You have some type of interface to data communications equipment. One of those type of interfaces is a V.35. Then this will go through your cloud, and you have some form of data communications equipment that's going to interface back to your data terminal equipment. Now, in a lot of cases, this could be a router. This could be a DSU, CSU. Learn about that later. And then the same thing over here. Or another scenario, you can think of this is the NIC card, this is the computer, and that gets it on the wire in some network. Or this is the cable modem at your house, and then you have that small router at your house that connects the cable modem. The cable modem makes a connection into the cloud. Alright. A couple other examples here. Here's a case where I did show controllers 01 DCE and the clock rate's been set. There's no static routes here. we've got a directly connected route and no default gateway's been done. Here, it appears, I can't tell for sure because I don't have all of their routing, but it looks like they have a static route for one of the WAN networks. So if we were to look at our scenario, it looks like maybe this router has a route pointing to that WAN network is what you don't need to do that. If you're going to put, if you have some static, if you have routes in here, some static routes, you would point them to the WAN, the LANs, excuse me, at the other location. Nobody wants to go to this network. Doesn't make any sense to go to there. What you want to do is you have probably you have devices here in your network, whatever those devices may be, and they want to communicate with some device here or some device here. Alright, take a look here at the last page briefly. Show IP interface brief, no shutdown. If they wanted to, they'd have to hook a cable to that Ethernet, either put a workstation on there, or you could do a no keep alive on that interface to keep it up. The other two serials are up, and again, this looks good. We have a static route pointing to a network. I don't have their exact diagram, but that looks good. They have a default gateway. This in their Cedar Falls, so that looks like this is probably pointing back up to Mason City. And then show their interfaces, and then here's the routes. And that is it.